Hi ladies, this is an extension on lesson 1.6. So as we covered in the last video, we defined all of these terms, kite, quadrilateral, or special quadrilaterals like trapezoid, kite, parallelogram, rhombus, rectangle, and square. Okay, so if you missed the last video, please go back and watch that. Here are the definitions for those. As you can recall from our last lesson, that we defined all of these terms. Now, today we're going to just do a couple practice problems. One of these you'll see in your homework, this one that we're going to do right now. This is number 11 or number 14 on your assigned homework problem from 1.6 from the textbook Discovering Geometry. And so we're going to use what we know about congruent rectangles and the definition of a rectangle and the properties of a rectangle and what we know about perimeter to solve this problem. So first of all, we're looking for the perimeter of one of the small rectangles, but we know the perimeter of one of the large rectangles. So let's think about what perimeter means in a rectangle. And we know that this is a rectangle because it's made up of 5 smaller congruent rectangles. So we know that this is a rectangle. We know that all 4 angles are 90 degrees. So in perimeter of a rectangle, we know that the perimeter equals twice the length times twice or plus twice the width. Okay, so we know the perimeter of the large rectangle. So let's call this the length. Let's call that the width because that's how I did it in class. So if you're following along with your notes from class, I'm going to call this the width and I'm going to call this the length. Now, if I know that L is like the bottom length of the rectangle, I know that L is also the top length of the rectangle because in a rectangle we have 2 pairs of congruent sides, 2 pairs of parallel lines, all angles are 90 degrees, so we know that the opposite sides in a rectangle are congruent by definition. And that means that the left and right are also congruent. So this is also the width. Now we have the perimeter of the large rectangle. So 2L plus 2W equals 198. That's given. That's a statement that we can assume is true because they told us it's true. Now, if you look at the length on top, notice the length on top has 3 groups, but the length on bottom has only 2 groups. Okay, so we need to distinguish between the length and the width of the smaller rectangles. So to distinguish between the length and the width of the short rectangles, I'm going to give one of them a variable x and one of them a variable y. Okay, I'm going to call this y. Okay, so each of the small sides of the small rectangle is y. And then the long side I'm going to call x. So let's think of an equation. Since we have x and we have y, we have 2 variables that we just created. And we can go ahead, you know what, let's actually go ahead and let's label all of our x's and all of our y's. So that's a y, here's a y, here's a y. Oh, nope, sorry, we're calling the y the short one. So here's a y right here. That means that's y, and that is y. And then the x's would be the longer ones. So this is an x, this is an x, and these would also be x's. Those longer sides of the smaller rectangles are x's. Okay, so I'm trying to find the perimeter. I know that the perimeter of a small rectangle, so this is the perimeter of the large rectangle. Now I know that the perimeter formula is the same. So the perimeter of the small rectangle is going to be 2 times x plus 2 times y. Okay, I know that's going to be true based on like the measurements of my small rectangle. I have 2 x's, x plus x, y plus y. 2x plus 2y is the perimeter of the small rectangle. Now, in order to find the perimeter of my small rectangle, that's the question, what's the perimeter of the small rectangle? I need to know what x and y are. Okay, so I'm going to use something from algebra called system of equations. I have 2 variables, so I'm going to need 2 equations. Well, I'm going to look at what I know. Right now, I know my length. I don't know the actual length and the actual width of the large rectangle, but I know that the length of my large rectangle, this L right here, I know I can write that 2 different ways. I can write it as y plus y up here, which is 3y, or I can write it as x plus x down here. Okay, I have 2 x's. All right, so there's one equation, 3y equals 2x. Now I need a second equation because I have 2 variables. The only other piece of information that I have with only 2 variables would be that perimeter formula. Okay, but I'm not going to use L and W because L and W are not in my perimeter of my small rectangle. So I'm going to try to get that into x's and y's. So I know my perimeter is 198. So I'm going to say 198 equals 2 times L. Doesn't matter which one you use for L. You can either use 3y or you can use 2x. They're the same. So I'm going to use 2 times L, 3y, plus 2 times W. Now my W is the height of my rectangle, and that's x plus y. Okay, if I look at the height of my rectangle, I marked all of my sides. Segment addition says that the segment length is equal to the sum of its parts. Okay, so that's where I get x plus y from. That's the height of my rectangle. Now I'm going to use the system of equations to solve. Here I have an equation 3y equals 2x. I'm going to solve for x or y. I like to solve for x. It doesn't really matter which one you solve for, but I'm going to solve for x. So I know that 3y equals 2x. So to solve for x, I need to divide both sides by 2. And I get the answer 3/2 y equals x. Okay, now I have an x value that I can plug into my x. Okay, so I'm going to go ahead and plug in my x value for x. And I get, oh, let's go purple. I get 198 equals 2 times 3y. This is all the same as the previous equation. I'm getting it from over here. Plus 2 times, now it's time to substitute my x in, which is 3/2 y plus y. And now I'm just going to simplify. 198 equals 6y plus 3y plus 2y. Remember to distribute to each term. I'm going to simplify some more. 198 equals 6 plus 3, which is 9, plus 2, which is 11y. And now I can divide both sides by 11 to solve for y. And I get y equals 18. All right, that's just my y value. Y equals 18. I can take this y value right here and substitute it in for y to find x. Okay, so I'm going to go ahead and rewrite that. I know that 3/2 y is equal to x. So x is equal to 3/2 of my y, which is 18. And when I solve that, I get 27. Okay, so let's go back up here to where we're finding perimeter, because that's the question. What is the perimeter of one of the small rectangles? So I'm just going to rewrite it down here so it's clear, so that I can clearly see it. Perimeter equals 2 times x plus 3 times y. Oh, plus 2 times y. 2x plus 2y. I know an x value, which is 27, and I know a y value, which is 18. So 2 times 27 plus 2 times 18, that's, let's see, 54 plus 36, which is 90. That's the question. What is the perimeter? The perimeter of one of these small rectangles, any one, doesn't matter which one, they're all congruent. So the perimeter of one of those small rectangles is 90 centimeters. Okay, so pause, rewind, go back, double check as you need to. But this is problem number 14 on the homework. So please jot down any notes or questions that you have, and then get those addressed next time I see you. Okay, we're going to do one more. And this problem is a coordinate geometry problem. Okay, so in this problem it says find the coordinates of triangle XYZ such that it is congruent to triangle ABC. Okay, so remember when we talk about congruence with polygons, the coordinates or the vertices and the sides have to match up. So if we're talking about an angle in this triangle congruent to X, we're talking about angle A. Okay, so it has to be at the same angle. Angle X has to be the same as angle A. Angle Y has to be the same as angle B. And angle Z has to be the same as angle Z. Okay, now if you're following along on the notes that you printed off, this is in 2018, September 12th, sorry, we are in 2019. So this is September 12th, 2019. If you printed the notes off online, you'll want to make this adjustment. I have since corrected it, but X and Z, those, or Y and Z, that last coordinate should be Z. Okay, so if it says Y on your note sheets, make a correction, it should say Z. We made that correction in class, so you should already have it if you were in class, but otherwise please do that. Okay, so now when we're looking for congruent triangles, congruent polygons, we know that the segments, the sides, and angles that correspond are congruent. Okay, so that has to be true. If you're talking about congruent triangles, any congruent polygon, their corresponding sides and corresponding angles have to be congruent. Okay, so we're not changing any orientation. We're not rotating the figure. We're not flipping the figure or anything. So it's going to be in exactly the same orientation for now as triangle ABC. So what we need to do to find the length of the segment is we need to count the rise, which is 4, over the run, which is 1. And that's exactly how we're going to plot that point. Okay, so we need to go up 4 and over 1. This is going to be point Y because point Y corresponds with point B. Okay, then to get point C, Z is already here, but just as a double check, let's count the rise, which in this case is -4, over the run, which is 3. So 1, 2, 3, 4, 1, 2, 3. Okay, and just as we expected, it is right at point Z. So here is our triangle. Now the question is, how do we know that the angles are the same? How do we know that angle X is congruent to angle Y? We know that because segment AB and segment XY have the same slope. And segment AC and segment XZ have the same slope. So when two parallel lines intersect with two parallel lines, they create congruent angles. Now, next lesson, or in chapter 2, it's chapter 2.4, we'll get into that a little bit more, 2.5 actually, a little bit more, but that's still in this unit. So just make a note of that, but you know that already based on what you learned in algebra. So we're carrying forward that information into our geometry lesson, just like we did in the last problem. So you would do the same exact thing for polygons. So any polygons, whether it's a quadrilateral or a pentagon or anything. We did it in this example with triangles, but you'll do it with other polygons as well. Same exact thing. You need to find the slope of the line counting the exact same rise over the exact same run. So please jot down any questions you have on this video and bring them to class, and we can go over them next time I see you. Thank you.